6.1 and 6.2 talk about our law of sines and law of cosines. So both of these are ways to use your sine and cosine like you did with right triangle trig, but this time they're in oblique triangles, which an oblique triangle just means that it is not a right triangle. So a non-right triangle. Whenever we have our oblique triangles, or really any triangle, if I have like this is angle A, the side across from it is called side A. We will use capital letters for all of our angles, lowercase letters for all of our sides. Do be careful with your C's to make sure that if it's a capital C, it is clearly larger, and if it's a lowercase c, it is clearly smaller. We have, first let's start with law of sines, which compares the sine of an angle with the side across from it. So the sine of angle A over side A is going to be the same as the sine of angle B over side B, which is the same as the sine of angle C over side C. So if maybe I knew angle A and side A, and I knew angle B, but I was trying to find side B, I would kind of ignore that last part of the proportion, and I would have a proportion over here where I could cross multiply and divide. Since we are dealing with triangles, these should be in degree mode, so do make sure you are in degree mode for these. For law of cosines, it kind of looks like your Pythagorean theorem, so c squared equals a squared plus b squared, but because it's not a right triangle, we can't just leave it at that, so it's minus 2 times ab cosine of angle C. The important thing to realize with this would be if I was like wanting to find side C. If I was wanting to find side B, then I would have b squared equals a squared plus c squared minus 2 ac cosine of b. So whatever side you're trying to find, the corresponding angle is the angle you're using for your cosine. You could use this same formula to find like angle C, but we do have it worked out for you as well where it's already solved for angle C, rather for cosine of angle C. So I would do all of this on the right side and then do cosine inverse. Let's try a few. So this first example, angle C is 102.3 degrees. Angle B is 28.7 degrees. And side B is 27.4 feet. Two things. One, I always draw my triangle like this. While it's not necessarily drawn to scale, like that doesn't really look like 102 degrees, given that it's not an obtuse angle, it doesn't matter because I have an easy way of setting it up and I know where all my sides and angles go. I just know it's not drawn to scale. When deciding whether to use law of sines or law of cosines, if I know a side and the angle across from it, that is going to be law of sines. So I'm going to want to set up law of sines. When I set that up, I don't have to set up all three ratios. I only need to use 2 to start. And I am going to try to find all of the sides and angles, but I would just start with probably sine of B, which is 28.7 degrees, over 27.4 is going to equal the sine of angle C, which was 102.3 degrees, over side C, which I do not know. From there, I'm going to cross multiply 27.4 times sine of 102.3 degrees. Make sure you're in degree mode. And then I'll divide by sine of 28.7 degrees. When I do that, I get that C is 55.75, and in this case it was feet. I do need to find side A and angle A. Angle A is probably something I could have done at the very beginning. It's the easiest thing to find because I know all of the angles in a triangle add up to 180. So I'm going to take 180 and then do minus my 102.3 and minus my 28.7. And I'm going to get that angle A is 49 degrees. So measure of angle A is 49 degrees. So there's angle A. I have side C. The only thing I'm missing is side A. which is across from my angle A, which I now know, so I can set up law of sine. So I'm going to have sine of 49 degrees over side A equals sine of 28.7 degrees over 27.4. I used my angle B and my side B just because those are the ones that were given to me, so I don't necessarily have to worry about if I made some sort of mathematical mistake when I was finding side C, but you could have definitely used your sine of angle C over side C. Same thing down here, cross multiply, divide. When you do that, you should get that A is 43.06 feet. Make sure you have found every side and make sure an angle and that everything is clearly marked. Another example. Angle A is 115 degrees. Side B is 15 centimeters. Side C is 10 centimeters. If you remember on the last one, I said if you know an angle and the side across from it, that's law of sines. Here, I know an angle, but I don't know the side across from it. And I know two sides, but I don't know either angle across from them. So this is going to be law of cosines. So to decide what I'm actually setting up with, whether it's c squared or b squared or whatnot, I know angle A. It's the only angle I know, so it's the angle I'm going to need to use. So I'm going to set this up as a squared equals b squared plus c squared minus 2bc times cosine of angle A. I'm doing that because angle A is the only side or only angle I know, so it's the only one I can use. So I don't know A. B is 15. C is 10, so 15 squared plus 10 squared minus 2 times 15 times 10 times cosine of 115 degrees. I can type all of that in, which is going to give me 451.785, and then I'm going to take the square root of that. Do not round until the very end. I don't care if you round when you're writing down your answers like here, but actually take the square root of the entire answer you had there, not a rounded one. I got 21.26 centimeters though for side A. Now that I have an angle and the side across from it, so I have sine of 115 degrees over 21.26, I can set that up to find angle B, and I can set that up to find angle C. So I'll start with angle B, so I'm going to kind of ignore this right here, and I'm going to cross multiply 15 times sine of 115, and I'm going to divide by my 21.26, which technically means that I have sine of B equals that, which was about 0.639. I'm doing sine inverse, so I'm going to do sine inverse of that answer, which is where I'm going to get that angle B is 39.76 degrees. From there, to find angle C, I have two choices. I can do law of sines like I've already set up over here, or I know angle A and I know angle B, I can just subtract to find the measure of angle C from 180. And when I do that, I got 25.24 degrees. Another example here, I know that A is 8, B is 19, and C is 14. I don't know any angles, so I definitely don't know a pair that's an angle and the side across from it, which means it cannot be law of sines, which leaves me with law of cosines. Also, anytime I have here, this is like all three sides, that should be law of cosines. Or if you look back at the previous slide, that was two sides and the angle between it, that should be law of cosines as well, if that helps you remember that instead of looking for an angle and the side across from it. So this is law of cosines. I don't know any angles though, so I want to set it up to find that angle. When trying to decide what angle I'm going to find, A, B, or C, you always start with the largest angle. If you don't, not every time, but there will be cases where that will mess up your answers. So do always start with that largest angle, which should be across on the largest side. So my largest side was this 19, the B. So my largest angle is going to be B. So I'm going to have cosine of B equals A squared plus C squared minus B squared. So since I'm trying to find angle B, I'm going to have that as my minus my B squared there. And then over, I don't know what's happening there, but that's okay, 2AC. So I'm going to have cosine of B equals, and then A was 8, so I have A squared plus 14 squared minus 19 squared all over 2 times 8 times 14. You can type all of that in on that right side all at once. Do be careful. If you're going to set up as a big fraction, that's fine. Or if you want to put parentheses around your numerator, that's fine. But when I type that in, I'm getting about negative 0.451. And then I'll do cosine inverse to find angle B, which is 116.8 degrees. Once I have angle B, I can set this up with law of sines. So sine of angle A over side A equals sine of angle B, which was 116.8, over side B, which was 19. Cross multiply. I'm going to have to divide, and then I'll have sine of A equals what you get there. Make sure you're doing your sine inverse so that you can find the measure of angle A. When you do that, you should get 22.1 degrees. And then finding angle C, since I know all the angles in my triangle are going to have to 180, I can just subtract those two from 180. I got that the measure of angle C was 41.1 degrees. I want to look at a couple of word problems, so do take a second and get this written down and try to draw a picture with it. So I have a pole tilting towards the sun, so I'm going to go ahead and draw my sun. It is tilting at an angle of 8 degrees from the vertical. So here's a vertical. The pole is tilting toward the sun where that angle is 8 degrees. Its shadow, which shadows lay on the ground, is 22 feet, and the shadow should be away from the sun. The angle of elevation from the tip of the shadow to the top of the pole is 43 degrees. I want to know how tall is the pole. So first thing, instead of just having that vertical line there with that 8 degrees, that angle, this is vertical to horizontal, so that's 90. That whole angle should be 98 degrees. And I'm trying to find this. So I have these two angles. Let's go ahead and subtract those from 180 to figure out what that third angle is. Should be 39 degrees. And the reason I want to do that is that 39 degrees is what's across from the side that I actually know. So when I go to set this up, sine of my 39 degrees over the 22 feet is going to be the same as that sine of, and here I'm going to use the 43 degrees because it's across from the x. And then I can cross multiply and divide, and I should get that x, or my pole, is about 23.8 feet tall. On this one as well, take a second and write down the problem and try to draw a picture. So a ship is traveling 60 miles due east. East goes to the right. So I'm going to put my ship is starting right here. It goes 60 miles due east. Then it adjusts its course to 15 degrees northward. So I'm going to, if I'm traveling this direction, and I turn 15 degrees northward. So that's where my new angle is, or my new course is rather. I have traveled 80 miles in that direction. I want to know how far is the ship